Hey, Algebra 1, got your Quiz 10 review. Just remember it's on Thursday, and what I'm doing is I'm going over the quiz review that I handed out in class, the extra one. So this is not the one that is in your packet. This is the other one. If you'd like to come and get that one, come by on Wednesday or after school today on Tuesday to grab it. All right? So number 1, so zoom up on that. We need to simplify this radical, or this square root of 48. So remember, first thing we do is the birthday cake. And I'm going to divide the smallest prime number. Smallest prime. Smallest prime is the smallest number that can be divided by only itself and the number 1. So examples of prime numbers would be 2, 3, 5, 7, 11. Examples that are not prime numbers would be 4, 6, 8, 10. And these are not prime numbers because I can divide a number into 4. I can divide 3 or 2 into 6. I can divide 4 or 2 into 8. And I can divide 5 or 2 into 8. But 2, 3, 5, 7, and 11, I cannot divide a number into. So go down here, do the birthday cake with 48. Divide by 2, I get 24. Make your next layer of cake. Then I can divide by 2 again. The next layer will be 12. And I can divide 2 into that number again, so I get 6. I can keep dividing 2 again, and then I will get 3, and then 3 goes on top. I'm sorry, I can divide 3 into 3, and then my candle goes on the top. So now, let's rewrite the square root, and inside I'll have 2, 2, 2, 2, 3. Now remember, you circle every group of 2. I have 2 2's here and 2 2's here. So that means I'm going to take 1 2 out here and another 2 out from here. So I'll have, oops, sorry. So I'll have a 2 and another 2. And then I still have this 3 inside. So again, I multiply the 2 and the 4. I'm sorry, the 2 into the 2, and it becomes 4. And there's my answer, 4 times the square root of 3. Now this one's just like the last problem, where first I'm going to have to do the birthday cake with the 18, but then when I bring the numbers outside, I need to multiply it times this 4. So let's do the birthday cake with 18. First number I can think of is 2 to divide. Then I'll divide, then I get 9. Then I'll divide, looks like 3, because I can't do 2 here. And then we'll do 3 again, because 9 divided by 3 is 3. And then the only number I can divide into that 3 is 3 again. And I make a wish. Okay, so now here, let's rewrite it. So now I have 3 times 2. And again, circle that group of 2 there. And I'll take one of those out. So now it's 4 times 3, because don't forget about the 4. And then I still have a 2 on the inside. So now 4 times 3 is 12, and I still have 2 inside. Okay. Now here with fractions. Here, when you do a fraction, you do the square root of the top, and then the square root of the bottom, or the square root of the numerator and square root of the denominator. So here, square root of 49, on the bottom, square root of 121. Okay, so now we do the square root of the top, square root of the bottom. Square root of 49 is 7. Square root of 121 is 11. And guess what? 7 over 11. I know some of you guys like that one. All right. Okay. Let's go on to number 4. Okay, so we're going to do this the same way we just did the last one, except now we have a 4 outside. So the next step, I'm going to put the 4 out here, and I'll do the square root of the top, square root of the bottom. Okay. So now, and remember this is negative 4 times the square root. Okay. So let's just remind ourselves by putting parentheses. Square root of 1 is 1. Square root of 64 is 8. just a little bit. Now, how do you multiply -4 times 1/8? That's a good question. Okay, so you are going to turn this 4 into a fraction by putting it over 1, and then you multiply across. -4 times 1, -4. And then 1 times 8, 8. And then reduce it. What number can you divide into both the top and bottom number? I can divide 2. So divide 2 into both. And -4 divided by 2 is, actually, you know what? Let's do another number, because I can actually divide 4 into both of those. Because you want to choose the biggest number you can divide when you reduce a fraction. -4 divided by 4 is -1. And 8 divided by 4 is 2. So -1/2. And just to remind you guys, as you go through these, I recommend that you try the problem yourself, and then come back and watch this, and just to double check you did it right. Okay, if you didn't grab this extra worksheet, then go ahead and just do it on a piece of paper and practice on that. Okay, but I do have the worksheet in my classroom if you want the actual worksheet to work from. Okay. Okay, so here I'm going to add 2 radicals or 2 square roots. Okay, so what I need to do in order to add those is the number inside has to be the same. Sorry about that. So this number in here and this number in here need to be the same in order for me to combine them and add them together. Okay, so what I'm going to do first is I'm going to take the 48 to the side, and I'm going to do the birthday cake with it. And if you notice, we actually did this already in the problem above. It was the very first problem we did. So if you're on the test or in the quiz and you notice that one of those problems is numbers is the same, then just go ahead and use the same one from the last problem. Okay, so here divide by 2, and then divide, so that gives us 24. And then we can divide by 2 again, that gives us 12, divide by 2 again, that gives us 6, divide by 2 again, that gives us 3. The only number I can divide into 3 is 3. And that gives us 1, or a birthday cake candle. So now I have 1 group of 2s, 2 group of 2s. So that means that not only 1 2 will come out, 2 2s will come outside. Okay, so I'll have 2 times 2 times the square root of the number that's left over, which is the 3. Okay, so that's for the 48. Now we have to break down the 4 times the square root of 27. Okay, so just remember, before we break it down, there is a 4 out here. Okay, we just don't want to forget about that 4, because after we bring out the number from breaking it down, we want to multiply it times that number. Okay, so smallest number I can divide here would be 3, and then that will give us 9. Then I can divide 3 into 9. That gives us 3. Okay, and then the smallest number I can divide into 3 itself is 3. And 3 divided by 3 is 1. Okay, so circle 1 group of 3. That means when 3 comes outside, that's going to go here. Sorry, there's a little delay from the pen not working. Okay, so now multiply the outside. 2 times 2 is 4. And then 3 times 4 is 12. And now what you do here is, now that the numbers on the inside are the same, I'm going to add the outside numbers, which we call the coefficients. And we're going to get 16. Apologize, my pen's having little issues. 16 times the square root of 3. Okay? Alright. Okay, now what we got to do is simplify this expression. Well, first we need to take a close look at what's going on here. So first, we want to identify what operations we have. Well, between this 4 And the bars, there's nothing there, so that means we're multiplying there. And here, we have subtraction. All right? But if we remember PEMDAS tells us to do parentheses, exponents, multiply, add, and then subtract. Sorry, multiply, divide, add, and subtract. But parentheses can also be considered absolute value bars. Okay? Okay, so let me put everything else in here. So let's put 2 to 2, and then multiply, and divide, then add, then subtract. Okay, so again, these bars could be considered like parentheses, so we want to do that first. And remember, this is -4 times whatever this is, so let's put parentheses to remind ourselves. Okay, so what's the absolute value of -3? Positive 3. Because remember, any number that comes out of the positive, or sorry, out of the absolute value bars is positive. Then we subtract 1. But again, let's go down the line. What do we have here? Do we have exponents? No. Do we have multiplying? Yes. The parentheses show us that. Okay, so -4 times 3 is -12 minus 1. And that is equal to -13. All right, same result from the problem you had on your unit review. Okay, so let's go over to number 7. Approach this the same way. And again, using PEMDAS. Let me scroll this over just a little bit. Using PEMDAS, we want to handle what's inside the parentheses or the absolute value bars first. Okay, and if you notice here, I have a negative and a negative. I don't like two signs. Okay, so what I want to do is combine those, and it's a negative and a negative, so that's going to become positive 9 plus 3. Okay, I didn't change the 4 times -5 yet. Still want to handle what's inside these bars. So then 9 plus 3 is going to become 12. Okay, now I'll do this. I'll multiply these two over here. So positive 4 times -5, well, that's -20. Okay, then the absolute value of 12 is 12. And then I subtract 12 minus 20. Well, that will give us -8. Okay. Okay, so now that's our result. That's our answer there, -8. Let's go on to number 8. Okay, solving the absolute value equation. So you know if you have absolute value and you're doing an equation or an inequality, you know you're going to end up with two equations to solve or two inequalities to solve. Now here, before you split it, sorry about that. Goodness, I apologize. Technical difficulties here. Before you split it, you need to make sure that we do not have anything out here or anything over here. There's nothing next to the bars. And remember, we said we need to isolate them. We need them to be by themselves on that side of the equal sign. Okay, so there isn't anything, so what we can do is go ahead and split it into two different equations. Okay, so this one is going to still have the x plus 3 inside, equals the 7. So remember, the equation on the left will not change. It will stay the same. And then over here, you'll have x plus 3 again, equals again, but then what changes is the -7. It means the 7 becomes negative. Okay, so now, solve each equation. Well, here I'd subtract 3. And the nice thing is we do the same thing all the way across. 7 minus 3 is 4. And then -3 minus 3 is -10. But remember, we want that to be combined as one answer. So our solution is x equals 4, comma, -10. Okay. Okay, now this one, if you notice, on the left and right of our absolute value bar, we have a number. Okay, so that means I cannot split the equation yet. I cannot split it like this until I remove those numbers from each side of the bars. Okay, so what I want to do first is I'm going to get rid of this 3. Okay, so I'm going to add 3 here and here. Okay, to both sides. Okay, so now I'm left with 5 times the absolute value of 2x minus 3, which is equal to 22 plus 3, which is 25. Then to get rid of the 5, it's 5 times this absolute value, so that means I need to divide. And I'll divide both sides by that 5. These 5's cancel out, and then I'm left with 2x minus 3, absolute value of that, equals 5. 25 divided by 5. Now, I do not have anything on the left and right side of the bars. So now I can split it. Okay, so now I have 2x minus 3 equals 5. And then we have 2x minus 3 equals negative 5. Remember, we switched that number on the right. So now, to solve this, I'm going to add 3 to both sides to get rid of the 3 from that side with x, because remember, we want to get x alone, and the first step to get x alone would be to get rid of this 3. So now I have 2x is equal to 5 plus 3, which is 8, and then 2x equal to negative 5 plus 3, which should give us negative 2. And then to get rid of this 2, ultimately I want that x alone, is divide both sides by 2. Same thing over here. Whatever you do to one side, you're going to do to the other. Okay, so then for x, the first answer is going to be 8 divided by 2, which is 4. And the second answer is going to be negative 2 divided by 2, which is negative 1. Alright? Hey, it ends up being the same problem, the same answer again, like on your review. Different problem though. Okay? Okay, so now here, these are inequalities. Inequality means we're going to have less than, greater than type signs. Okay? Or less than or equal to, or greater than or equal to signs when you see inequality. Okay, so here, this is x minus 3, the absolute value of x minus 3 is greater than 5. Okay, so again, we solved this the same way like the last one. There are no numbers on the left or the right, so I can go ahead and split it. So x minus 3 is greater than 5. Remember, this one stays the same. And whatever's inside the bar stays the same, so x minus 3. But what changes is not only that number 5 becomes negative, but also the sign, this inequality sign, will flip the other way. Okay, so here it's greater than, here it's going to be less than. Okay, so now let's solve it by adding 3 to both sides to isolate that x, get it by itself, and x is greater than 8, and x is less than negative 2. So now let's go ahead and put that on the graph. And negative 2 will go on the left because it's smaller, and positive 8 on the right because it's bigger. And we're going to put an open dot for both because it's a less than, not an equal to. And then starting with the negative 2, it says x is less, so less is to the left. And this says x for 8, it says x is greater than 8, so we point to the right because that's greater. So I shade out here to the right, I shade out here to the left. So now I know, since I shade separately, my answer is going to stay separate. So what I can simply do is go back up here and just write or between those two inequalities, and that'll be my answer. Only if they're separate. If they're together and you shade in the middle, you need to write a new answer, because this wouldn't be the answer, okay? But they're separate, so I can go ahead and put or in the middle. Okay? Okay, now this one, again, same thing. I want to be able to split it. However, I've got this 10 out here, and it's 10 minus the absolute value of 5x. So I need to get rid of the 10. Now, this is 10 minus. Okay, it's not negative 10, it's 10 minus. So that means I would subtract the 10, because it's positive. Okay, that gets rid of that. So now I have negative absolute value of 5x is greater than 5 minus 10 would be negative 5. But then I still need to get rid of this negative that's in front of the absolute value. That's right here. Okay? Okay, so if there's a negative 1 there, then that means that I need to get rid of it. So to get rid of it, I get to divide by that negative 1. And let's actually do that all in a different color. Okay, so divide negative 1 here and there. Okay, so those negative 1s cancel out. And now I have absolute value of 5x. And then over here, negative 5 divided by negative 1 is positive 5. But what's something that's important to remember is that when you divide an inequality, or any problem that has this sign, if you divide by a negative, it is going to switch this sign. It is going to flip it. Okay, so it'll go from greater than or equal to less than or equal if you divide by this negative, any negative number. Okay? Okay, so now our absolute value is all cleaned up. It's by itself. So now I can split it into two equations. So I'm going to split that over here. So I'll have 5x is less than or equal to 5. And then 5x is greater than or equal to negative 5. Remember, we switched that. All right, so now I divide by 5 on both sides. 5's cancel out. X is less than or equal to 1. X is greater than or equal to negative 1. Go back over here. Negative 1, positive 1. And it's an equal to sign, so that means it's going to be a closed dot. And here it says x is less than positive 1. So for positive 1, if it's less, it's to the left. And then for here, x is greater than negative 1, so it's to the right. So shade in the middle. And then we see that it meets in the middle. The shade does, so that means our answer will stay together. Negative 1 on the left, 1 on the right, x in the middle, and then you're going to write less than, or equal to on the left and right. Okay, let's go on to number 12. Okay, again, we want to split it, but in order to split it, we need to isolate this absolute value for these bars. And we have a 5 over here, so we need to get rid of that 5, so let's subtract it from both sides. So now we have the absolute value of 3x plus 3. And that is less than or equal to 8 minus 5, which is 3. And now, since we got those bars by themselves, we can split it into two equations. And remember, the one on the left will stay the same. So 3x plus 3 less than or equal to 3. And then over here, whatever's inside the bar still stays the same. But then the number on the right and the sign will change. So instead of less than, it's greater than or equal. And instead of positive 3, it will be negative 3. And now we just solve each equation. So first, subtract the 3. Sorry, not equation, inequality. It's different. Equation has an equal sign. Inequality has a less than or equal greater sign. Okay, so now we have 3x less than or equal to 0. And 3x greater than or equal to negative 6. Divide both sides by 3. 3's cancel out. And then we have, I'll write it actually below, we'll write it to the side. X is less than or equal to 0 over 3, 0. And x is greater than or equal to negative 6 over 3, which is negative 2. Okay, so let's go to our graph. Oops. So now you have to think, okay, which one is bigger, 0 or negative 2 bigger? 0 is actually worth more than negative 2. Okay, so it's a less than or equal to sign, so it's going to be a closed dot, or solid. And starting with 0, it says x is less than 0, so we point to the left. And here it says x is greater than negative 2, so greater is to the right. Shade in the middle, because they meet in the middle. And so that means our answer will be together. I can go right underneath, rewrite the numbers. Negative 2 on the left, 0 on the right, x in the middle, less than or equal, less than or equal. Okay, now this one, let's kind of get this out of the way. Here, the absolute value is isolated. There's nothing on the left, nothing on the right. So I can go ahead and split it. X over 3 minus 2 less than or equal to negative 1. And then x over 3 minus 2 is greater than positive 1. So we started with the negative, so now it becomes positive. And we started with less than, and it becomes greater than. Okay, so again, just solve it like an equation. Plus 2 plus 2 plus 2 plus 2. I have x over 3 here. Negative 1 plus 2 is 1. Okay, x over 3, 1 plus 2 is 3. And now what we need to do is get rid of this 3 on the bottom. So instead of dividing, I need to multiply. So times 3, times 3, times 3, times 3. Those 3's cancel out. Okay, x is less than 3, and x is greater than 9. Because 1 times 3 and 3 times 3. Then go to your graph. 3 goes on the left because it's smaller. 9 goes on the right because it's bigger. This is going to be an open dot. Okay, let's start with 3. Well, 3 says x is less than 3, so that means x is going to the left. And this says x is greater than, so for 9, so it's going to the right. So this goes to the left, shade to the left, goes to the right, shade to the right. And they're separate. It doesn't meet in the middle, so that means our answer is going to be an OR answer. Okay, so right here, I'm going to put OR. Okay, and that is my answer right there. Okay. Okay, last one. Okay, so it says, what is the solution to this inequality? Well, if you notice, the shading is in the middle. And so if the shading is in the middle, that means our answers are together. Okay, so let's go down and bring the 3 down here. And then the 3 comes down here, and you know x is in the middle. And you see that we have a closed dot on both sides, so that means it's going to be less than or equal to. So less than. Sorry, I've had so much delay on my pen. But that's, oh, there we go. All right, there's my answer. Okay, that's it. And just remember, you guys can also practice by going to ixl.com, so I don't have it up, and going to the Google Doc and Google Classroom. Go there and you can use that to practice. So if you guys go to Google Classroom and pull it up, let's close all these tabs. You can go to the Classroom, click on the Google Doc, open that up. That will show you all the IXL assignments you can use to both practice and get extra credit for class. Okay? Have any questions, just hit me up on Remind. Or come and see me. All right, bye.